Next, let's look at equations of this form. dy dx is equal to g of ax plus b. You can probably guess that you make this substitution and then solve. So what you do is you substitute z equal to ax plus b, y, and then the equation is separable. And then, or just and the equation is separable. All right, so I'm not going to get into any sort of theory there. Let's just look at an example. This is number 18. Pretty much just going through the even ones right next to the ones I assigned for homework. So example number 18, this is on page 76. Nagel, and again, that's just mostly for my reference. Okay, so solve dy dx equal to, and then this, you can see this will be in that form, x plus y plus 2 raised to the power of 2 squared. So that's your basic form with your coefficients and your variables. And so we can let z equal x plus y plus 2. And then you end up getting that dz, well, you want to calculate dz dx. That would then be z squared plus 1. After you do the substitutions and simplify, and so what you end up getting is separable, so then you end up having 1 over z squared plus 1 dz equal to dx. Integrate both sides. 1 over z squared plus 1 dz, integral dx. And that one, anybody recognize that integral? That is arctan z equal to x plus c. Okay, so then that's if and only if arctan x plus y plus 2 is equal to x plus c. So of course that's implicit form, and you can, you have to state some of the hypothesis or domain issues of tan inverse and all that, but you still can solve it. So from there, we have that well, this is tan, so I'm looking at my work. Okay, so then we end up getting that x plus y plus 2 is equal to tangent of x plus c. Okay, so from there you can solve for y and have an explicit solution. So y is equal to tangent of x plus c minus x minus 2. And that's our explicit form. Okay, so let's continue. Next, we're going to look at a Bernoulli equation. So Bernoulli equation. And what that is going to be. So this one will have a specific form. So here's the definition of Bernoulli. So definition 5 from the book. So it says a first order equation that can be written in the form, I'll just say of the form. Obviously, you can move stuff around. So if it can be written in this form, dy dx plus p of xy equal to q of x y to the nth, where q of x and p of x are continuous on an open interval. So they're continuous on an open interval a to b. And n is just a real number. I think most of the time in this book, n will be an integer, but positive integer. All right, so then if n equals 0 or 1, then this equation, so basically it's gone. It's basically just linear. So let's see. So if this is just 1, then this whole thing's linear. If this is, and you just bring that back over. If it's 0, you get 1 here, and then you just get that q of x. So if n is 0 or 1, then that, I'll just label it star like that, then that equation is linear. Okay, if not, then substitute. Okay, so if not, substitute v equals y to the 1 minus n. Okay, so if you do that, you end up getting a linear equation. So you get, I'll just show you. So you get dy dx plus p of x y equal to q of x y to the n. First divide by y to the n. This is our process. Then you have y to the negative n dy dx plus p of x y to the 1 minus n is your q of x. With v equal to y to the 1 minus n, that's basically v equal to y and then y to the negative n. And then when you do your substitution, you get dv over dx equal to dy dx, y to the negative n, plus y to the first negative and y to the negative n minus 1. All right. So I'm just substituting in, and I'll show you where it simplifies down nicely. Like this, and then minus n y to the negative n. So then it's 1 minus n y to the negative n dy dx. All right, so then spend a little time going through here and take a look at how this works. So do your substitution, you end up getting y to the negative n dy dx equal to 1 over 1 minus n dv dx. And then substitute again, substitute back, and you get 1 over 1 minus n dv dx plus p of x v equal to q of x, which is linear. So then, from there, you would use the techniques of linear to solve. So we'll look at the next example. This is number 22, page 76. And we'll do it in the next video.